Hi, everybody. Like announced, my name is Cory Lambertson. I'm the General Manager of Americas for Asiga. And first and foremost, thank you so much for taking your time out of your day to be able to sit in on this presentation. Today's presentation, we're actually going to cover the ins and outs of a little bit of the technology that makes Asiga so special. And then we're going to talk about the different materials that are available for Asiga. And then at the end, we'll finish off the presentation with a workflow in our Asiga Composer software. So you guys can see how simple and easy it is to use the nesting software that comes with Asiga. So let's go ahead and let's push forward. All right, so why 3D printing in dentistry? That's a common question we get, and it's why is it so special, or why is it needed? And the reason why is because it's applications galore. As the materials change and advance throughout the years, or throughout time, we're actually going to have more and more indications that are available for 3D printing. And the other thing is that every patient is unique. My oral cavity is different from your oral cavity, which is different from the next person. Therefore, 3D printing is almost a direct fitment for dentistry, and it works almost perfect with it. So when we look at 3D printing, we do have to remember that 3D printing is actually the actual CAM aspect, the output aspect of a CAD design. And so before you can actually get a 3D printer and use a 3D printer in your facility or office or your dental laboratory, you have to have a starting point. And that starting point is always going to be with the patient. It will then be pick up the oral cavity with either an intraoral scanner or a manual impression. From there, the scan data is going to transition into a CAD design workflow, and then you're going to output the CAD design. That is where the 3D printer fits in. So after the CAD has been outputted, it's going to move to the 3D printer, which is where it's going to actually produce the indication that's necessary. So when we look at that, the workflow for a clinician aspect or from a dental laboratory aspect is actually going to be the same once it gets to the 3D printer. So for that, after 3D printing the indication, we're going to move on to finishing the indication and then providing it to the patient. There are some special requirements that are necessary for 3D printing dental devices, and that's something that Asiga actually takes pride in. And so we actually make sure that we meet these requirements before ever producing a product or ever having it leave our facility. And so the very first thing that we look at is accuracy. If a printer is not accurate, it's ineffective and it cannot be suitable for your patients. And so that is the number one aspect and target that we try to meet before ever producing any sort of product. The next thing we look at is repeatability. And so the printer that we develop or the materials that we developed or the partners that we work with, we need to make sure that their products in our printer have a repeatable performance with it, which is going to be great for your patient safety. Speed is also an important factor. And so the faster the printer is, the reduced turnaround times there are, and the faster production you can actually have at your dental lab. And then the most important aspect, I think, is that the printers have to be open. And so when we look at an open source printer, that does not mean just on the software side. That means actually on the material side. That's what we're looking at. Asiga is the only true open source material 3D printer used in dentistry that is a professional grade 3D printer. And with that, what that means is that you can use any resin from any manufacturer and use it inside of your 3D printer. We're going to cover some of those manufacturers today, some of the leading manufacturers that are validated with our system. Beyond that, a lot of people ask us, well, why do you want to be open? You know, there's so many, I guess, variables that can change with an open source printer. Why do you want to be open? And so what we have found with being an open source printer, we give the dental laboratory the ability to choose what is correct for their patient and what is right for their patient. As a 3D printer manufacturer, we cannot claim what is best for the patient. The dental laboratory needs to be able to make that decision on their own. And so by making an open ecosystem, you can use any resin from any manufacturer, choosing what is best for your patient. So when we look at the 3D printers from Asiga, let's talk a little bit about the technology. So the Asiga 3D printers actually use a DLP projector. DLP stands for digital light processing. And how that works is that every layer is projected as a pixelated image into the 3D printing resin, creating the structure. And so how that kind of looks in the most basic form that we can draw up is that we have a build platform, and that build platform is going to move up and down during the layering process. Below the build platform is a vat of resin. And then below the vat of resin is actually a DLP projector. What it's going to do is it's going to actually project an image when the build plate is at the proper layer thickness, curing a layer. It will then separate and reapproach and repeat that process until the object is completely created and printed. That's a pretty generic form of 3D printing, or DLP 3D printing. It's a very, this is a very general definition of how it works. Now, there are benefits of DLP technology. Part of the benefits are, or one benefit is that it's fast. With a DLP 3D printer, you can go ahead and print a full layer all at once in just a matter of seconds. And so you can expose the whole imaging plane in a matter of seconds. Beyond that, because you're using a DLP projector, you'll have XY stability. That means you're going to have no variation from the edges to the center. You're going to have a nice actual dimensionally accurate mesh that's being projected onto the imaging plane to create the structures. And then beyond that, you have a wide range of UV LED options that are available for your 3D printer, really ultimately giving you the widest range of resins available to be used. Now, this was just a general terminology and general definition of DLP technology. So what makes us unique? What makes Asiga different from the rest? And so part of that is that Asiga has proprietary layer monitoring technologies that are integrated into the printer itself. And so these technologies monitor the layering process, ensuring that every layer is formed accurately, regardless of the material viscosity and regardless of the layer surface area and how large the area is or how small the area is. So something that's made that unique is our the smart positioning system, which is a technology that actually monitors every layer that's being formed and created. And so how it'll actually work is that we'll actually detect the layer exactly when it's reaching the true layer thickness, making the most accurate layer possible. When we look at our competitors in the market, they have an assumed Z position. As we can see, we have this little, I'm going to call it a little teepee hut that we're 3D printing. And as you're looking at it, you can notice around the edges that there's almost like different layer thicknesses throughout. All of our competitors in the dental industry use an assumed Z position. What that means is that they have a layer thickness that they're trying to achieve, and their printer has a mechanical distance that it's supposed to travel. However, it can't take into consideration of deflection or a vertical pressure due to the viscosity of resin. And so you'll actually have uneven layering that's happening during the layering process when we look at our competitors' printers. When we look at an Asiga printer that uses the smart positioning system, it actually has the ability to detect the exact layer position. We know exactly a known platform position, and we're able to detect exactly when it's reaching the most accurate layer formation possible, or the true layer thickness that we're trying to achieve. So I have a quick video that shows this. This is shown on our Asiga Pro 4K, and this is also available on our Asiga Max as well. It's the exact same technology. How it works is we have the build platform, we have a resin vat below, and then we have 4 pressure sensors and a DLP projector at the bottom. So when we're going through the layering process, the build plate moves down, and there's resin that needs to escape the imaging plane before it actually exposes. We can see on the 4 corners, there's pressure sensors, and it detects the movement of resin, the deflection of resin, and it knows when that deflection is gone and it is relieved before the actual projector fires on, curing the layer all at once. Now it's going to repeat this process all the way throughout the build until the object is completely printed. It's actually pretty wild how it works. Not only can it detect approach, it can also detect separation, which allows the printer to speed up throughout the print process as well, making it one of the fastest printers in the dental industry as well. Awesome. So beyond that, we also have a layer monitoring technology, which we call it the integrated radiometer. What we'll actually do now, after the printer is detecting approach and separation forces, we can also detect the light intensity of the projector that is curing the layer all at once. So over time, LED lights, they degrade, they become weaker in time. And so what we'll actually do is we'll take an internal tool called a radiometer. A radiometer measures the intensity of light, and it's going to be placed on the projector, and it measures the power coming from the projector before we actually start the print job. And so what will happen is if the LED is decreasing in power over time, and this is just a natural characteristic of LED lights, they naturally diminish over time, we will actually automatically adjust our curing times to make sure it's getting the proper exposure and the proper dosage of light. What that will do is it'll ensure that the printer in 5 to 10 years, 20 years down the road is performing exactly like it did out of the box. It's going to detect that change in LED intensity. It's going to automatically recalculate and recalibrate the exposure time needed for the given resin that you're using, and it's going to cure the layer properly. Without this type of technology, you'll actually have failed prints. And so you'll have issues where you'll have delamination between layers or objects not sticking to the build plate. And this is our answer to that. From there, at Asiga, we use industrial grade LED lights. And we actually have our printers in the ultraviolet spectrum, which is 385 nanometers. This allows us to print accurate, clear resins. And so with printing clear resins, if you're using a non-UV light source, you'll actually get what is called light bleed through the layering process. By using a 385 nanometer industrial grade LED light in our projectors, we're actually able to print water clear like resins and print them accurately. Beyond that, our printers have a very small pixel size. So the smaller the pixel size, the better the definition you'll actually get. And if you take a look at this in like a general term or general formation, if we look at, let's look at television screens, for example. If you see a television screen that is 1080p, and then if you look at the same size screen that is 4K, you're going to notice if you look up close, it's made up of thousands of little pixels or little dots that create the image. And on the 4K television screen, it's going to be a smaller pixel. It's going to be a denser pixel size, and that's going to allow for a greater definition. So the smaller the pixel you have, the more accurate the structure will be. And so, for example, our Asiga Max is a 62 micron pixel, and our Pro 4K 80 has a 57 micron pixel, extremely small, extremely dense, allowing us to create some of the most accurate structures 3D printable. And beyond that, because we're our open source 3D printer, you actually have precise material curing, so we can actually adjust and make changes and actually accommodate to any material curing behavior on the industry, which is really unique. So if we combine all of this together, we actually went through and had validation performed by 3Shape. And with that, within a 50 microns, so plus minus 50 microns of the original CAD file with our printer and our model material, we're actually able to receive a 93% direct match. That is extremely accurate and only a 31 microns of deviation, which is phenomenal. And so when we look at that, most of our competitors will actually try to achieve that within 100 microns. We're able to achieve it within 50, which is phenomenal. So why 3D printing in dentistry? Once again, that question comes back to us. And it's really because materials unlock applications. So we have over 500 fully validated and approved materials for the Asiga 3D printer. And if there's a material that you're looking for that is outside of our validated range, guess what? We have documentation that shows how to perform the validation process. And as you become comfortable with that actual process, you could validate your own material in about 20 to 30 minutes and start printing with it. We are validated with the leading resin manufacturers, for example, like Whitmix, Dentka, Ceramco, Dtex, Dentona, Keystone, GC, Colzer, Bago, Voco, Nextdent, and Dreve, Graphene. It goes on and on and on. And actually, this list expands almost every day, which is really unique. We're the only printer in the industry that is completely open to that point. So I have a quick video that shows how simple it is. So if you wanted to import in your own material profile, it actually takes about 20 to 30 seconds to be able to do so. And I have a quick video demonstrating that for us. So this is showing our Composer software. And let's say we wanted to use a different material. Let's say we want to use the Key Splint Soft from Keystone. inside the Composer software, you'd open up the build parameters and you would log into your Asiga account, which is where you would navigate to the material library and you would find the Keystone material profile. From here, when you find the Keystone library, you'll locate the material that you want to install. So for example, actually, we're going to use the key splint hard for this instance. From here, we'll go ahead and drop it into our material library. And now inside of the Composer software, you'll be able to locate the key splint hard and start utilizing it right away. It is that simple. Now in this video, it's actually slowed down just so we could follow along, but in live time, it probably takes about 20 seconds to do that process. Really easy to do. So from now till the end of this slideshow, I'm gonna go ahead and we're gonna talk about different indications that you can print easily with the printer. There's actually no indication that you can't print at this point. And with that, we're going to talk about some of the materials and manufacturers that are validated and have materials for that type of offering. One of the biggest, I guess, confusions is when you buy a piece of equipment as versatile as the Asiga line of 3D printers, is where do you find or what materials do you want to use for each indication? And so I'm hoping that this part of the presentation will kind of help you be pointed in the right direction on where to navigate to find the materials that you want to use for your indication itself. So when we look at dental models, for example, that can be fixed, removable models. It can be study models. It can be orthodontic models. It can be aligner models. It can be any sort of dental model or dental cast that we're trying to replicate. And so we have manufacturers, for example, as like Asiga makes a model material, Whitmix makes a model material, Kulzer, Keystone, Drebe, Detax, Dentona, Protheger, Nextet, and Voco. They all make a model material. In fact, there's actually more on the list that's available on our website. Unfortunately, I couldn't fit them all on the screen without being too cumbersome, but almost every resin manufacturer most likely makes a model material. And so if you're not satisfied with one model material, you can go ahead and try a different one. So for example, let's say if I wanted to try Keystone's new, the Key Model Ultra, and we're doing vacuum forming on it, for example, you could go ahead and try that Keystone material, and there's no limitations to it. It's just a matter of downloading the profile and start using it right away. From there, we also have Castable Patterns that you can print. So that would be like RPD frameworks or bridge frameworks or crown frameworks or copings, individual crowns, any sort of lost wax technique, even jewelry. I know some of you dental lab technicians like to dibble dabble in a little jewelry. Well, guess what? You could go ahead and download a profile or download a castable from online, maybe a ring, and you could actually go ahead and print it in a castable resin and perform the lost wax casting technique and have a gold structure. You can also use these castable patterns for pressing as well. So they're not limited just to gold casting or metal casting, but you can also use this material for pressing. So for example, that brings us back to that similar pattern, similar list. You're going to see that some of these manufacturers make more than one resin. So for example, Asiga, Whitmix, Keystone, and Drebe, they all make castable resin along with Detax, Dentona, Protheger, Nextet, Voco. There's actually more than what's on this list that make a castable resin as well. Really be finding which resin works best with your investment that you're using. Beyond that, what if we wanted something a little bit more permanent? What if we wanted to create a temporary crown or bridge? What if we wanted to create a prototype to be used in the intraoral cavity for your patient? Well, guess what? You can absolutely do that with an Asiga 3D printer. When we look at temporary materials, for example, Denka makes a temporary material, GC makes a wonderful temporary material, Drebe makes a great material, Detax makes an awesome temporary material. And if we look at something maybe a little bit more permanent, for example, well, there's Bago makes a permanent restorative crown material that is FDA 510K approved. Graphene and Ceremco, they both make a permanent crown material that are pending FDA clearance. And Vericom also makes a temporary material that is great as well. And so when you're looking at something that's going to be used in the intraoral cavity, something that you'll want to look at and do research before you actually get it is to make sure that the material has an FDA 510K clearance. And part of that registration is that it was validated on an Asiga printer with a specific curing unit with that material. And so you'll have to do a little bit of homework before you start using it to make sure that you're covered and safe. And ultimately, that's going to be providing safety to your patient. From here, let's talk about digital dentures. Can you print digital dentures or fabricate digital dentures with a 3D printer? You bet. Whether you're doing a try-in denture or the actual final denture, even flexible RPD framework materials are coming down the line. So that's something to look for in the future. When we look at denture materials that are available, that'd be a company like Denka, who actually pioneered the digital denture for us. And so they were the first company to produce a 3D printable denture, which is really cool. And then beyond that, a lot of companies have expanded their portfolio, like Ceramco, DTax, Voco, Drave, Graphy, Colzer, even Asiga. We have our own digital denture resin. But what about something a little bit different? What about something a little bit stronger, even considered maybe a little bit more permanent? There's the holy grail of Dentsply Sirona's Lucitone digital print material, and that has been validated on the Asiga 3D printer, and it will be available in mid-December. And so we're waiting for that official launch from Dentsply. But if you're looking at getting into digital dentures, but you're kind of leery about the materials in the past, well, Dentsply has their material available, and it's a phenomenal material. It's something that you can go ahead and take a look at and start using mid-December. Custom trays, you bet. So the custom trays, there's material providers, once again, like Asiga, Whitmix, Keystone, Dreve, DTax, and Tono Procedure, Nextent, Voco, and many more. The custom tray materials, so when we look at like that list, just about any material manufacturer makes a model material, a castable material, and most likely a custom tray material. Those were probably the three most popular materials when 3D printing got into dentistry, along with the surgical guide. And so those four indications will be very common. Something that I didn't touch on when we were looking at the permanent crown material is also using it for implant work. So let's say if you want to do a screw retain bridge workflow, that is absolutely achievable with those materials as well. For surgical guides, you can absolutely print surgical guides, and there's multiple companies that make the material for that as well. And beyond surgical guides, what if I want to do crown lengthening? Well, you bet. You can absolutely do crown lengthening as well. So if you want to create a gingivectomy guide, you could actually go ahead and produce that through a CAD design, 3D print it, and provide it to your doctor, which is really cool. Aligner therapy in orthodontics, there's plenty of materials in that realm as well. So when we're looking at aligner therapy, you can actually do traditional vacuum forming on top of the models. Two companies that stick out in mind that produce an excellent model material for vacuum forming would be like the Keystone model, Key Model Ultra. That has a separation agent in it that will help relieve the separation of the vacuum formed appliance to the actual model. And Asiga, we produce a really nice model material for vacuum forming as well, called Dentaform, that is heat resistant, which also helps aid in that separation process. On the top photo there, we can see that's actually an indirect bonding tray. So a lot of people at dental shows, they'll see that and they'll be like, oh, that's a really soft splint, too soft, you can chew right through it. It's actually not a splint, it's an indirect bonding tray, which is CAD designed with brackets, bracket placements, where you actually place the brackets inside of the indirect bonding tray. And you'll use that as a guide to place the brackets into the oral cavity for your patient that may be receiving braces. It's a really cool material, and there's multiple companies out there that make it. Make the indirect bonding tray materials. That'd be like Dentona, DTax, Nextent. In Asiga, we have our own material for that as well. What about directly printed aligners? There's a company called Graphy based out of Korea that is working on their directly printed 3D printable aligner material that has had promising results. It looks phenomenal. I've read a couple case studies on it, and it is mimicking identical to a vacuum formed application. And so that material is validated on the Asiga, and they're working through their FDA 510K. Hopefully to have that soon where we can start printing that in the laboratory in the States as well. Splints and night guards and occlusal guards. As you probably know, Keystone makes a great material, the Keysplint Soft. And they also have a hard material, the Keysplint Hard. And then also Whitmix makes a hard splint as well. called Splint. It is a hard material, and they were one of the first companies to actually have a FDA 510K on the Splint material. Both materials are really nice. Now, when we're looking at that list, you're probably wondering, where can I get those materials, or how can I get them? So if we look at what is actually sold by Zahn, we have Keystone Materials, or they have Keystone Materials. They have Dentsply Sirona for that, for the Lucitone digital print materials. They also sell the Whitmix resin, Dreve, Colzer, and GC. So if you're looking for some of those materials, you'll definitely want to talk to your Zahn sales rep and figure out what material is going to be best for your patient or workflow that you're trying to achieve. So what's next? Well, remember, materials unlock applications. What will we be able to print next? And I had to throw this in Back to the Future. You know, if only we could see in the future, but really what's going to happen is that the printers from Asiga, they're future proof. And so by buying an Asiga printer and being that it's open, you're going to be able to use any current resin and any future resin. In fact, majority resin manufacturers start off with our printers for resin development and resin fabrication before moving on to any other printers in the industry. And with that, there's going to be a wide range of chemistries that become available. And so chemistries today are changing, whether it's a different washable formation or a biocompatible material, or just a stronger denture or a stronger permanent crown. There's going to be so many changes that are coming out that it'll just be a matter of time before we have those next generation materials that really take 3D printing more into that permanent restorative work, which is really exciting. So I do have a couple, I'm going to do a couple, I guess, minutes on a hands-on Composer demonstration. And so I'm going to go ahead and show you guys how to use the Composer software and give you some tips and tricks for nesting the different indications. And then we'll go ahead and conclude our session with a question and answers. So let me minimize out of that. And so I already have a couple of jobs pre-nested, and this was just to allow for time. I didn't know how long it would take to go through those slides. And so the first build plate I have is actually a build plate of models. And we're going to talk about the different techniques that should be nested. And this is the actual look of the Composer software. And so if the Composer software is new to you, on the top bar, these are going to be like navigation planes. And we'll also have like function planes to like add supports or to auto nest or to send to the printer, for example. The Composer software has a parts list, which allows you to show visible any active items that you're working on. Also, it gives us a property value. It gives you the X, Y, and Z dimensions of the structure that you're selected on. And we also have a controllable transform panel, which will allow us to rotate or move the structure around on the screen with ease. I like to go by freehand, and so I will be using the mouse to move and rotate my structures. And so, for example, to move a structure, if you left click and hold on it, you can move it. And then if you were to left click and hold and then right click and hold, you can rotate the actual indication on the screen. And so when we're looking at models, anything that is used for fixed prosthetics, crown and bridge, implant cases, I always want those to be printed horizontally to the build plate. And so we can see that we have all of those indications placed horizontally. If it is a removable prosthetic, let's say if we're doing a case for aligner therapy, or we're doing a case for an RPD framework, or a denture, or a study model, for example, you can absolutely print those in just about any orientation. A lot of people like to print them vertically. So let's take, for example, I have a model here that's for a surgical guide. And if I wanted to actually flip that model so it was vertical, I can go ahead and left click on it, and then I can right click on it and hold until it's vertical. And we can see it turns purple. That gives us a sign that it's actually sticking through or penetrating through somewhere in the build place. I'm gonna do the same here with this model, for example. And then we will apply supports, and the supports will automatically move the model above. Now, if you're concerned about it, you can manually lift the model up so it's actually off of that. But I'm gonna leave this one through just so we can see that demonstration of it automatically popping it out. Another tip, when we're looking at dies, depending on your die design function, and depending on what CAD software you're using, it may leave a very small little pin that's going to try to attach the build envelope. It is sometimes necessary to actually apply support pins to the bottom of the dies, which will help it adhere to the build plate during the printing process. If you do have too small of a surface, think of it as almost like Velcro. That die will eventually pluck from the build plate and be trapped in the resin vat. And that would happen with any sort of 3D printer, not just the Asiga, but any 3D printer in general. If you have too small of a surface area touching the build plate, it could potentially fall off. And so let's say, for example, I wanted to add some supports to these structures. I'm going to go ahead and add some supports to these dies here. And then I'm going to add supports to the 2 models that are vertical. And the other 3 models, I'm going to keep touching the build plate. And so to do that, I can go to Generate Supports. And I'm going to go ahead and select on Selected, which will allow me to select the structures I want. If I hold down the Control key on my keyboard, I can select, for example, all my dies and my 2 models. Another little tip, I'm going to turn off Model Inner Support in here. And if I simply hit Apply, it's going to automatically support the structures. If you have Model Inner Support turned on, it may actually create supports in undesirable areas. So for example, for that bicuspid, it may actually pass through the model instead of actually going straight to the build plate. If I did not want the supports to be on the occlusal surface on one of these models, for example, I can right click on it and tell it to remove the support file. Oops, let me undo that real quick. I had all of them selected. I'll left click on the one I want to remove, right click, remove support file. And then if I was to actually tilt this model back a little bit, for example, and then reapply it just to that model alone, because remember I have selected on, we're not going to have those support structures possibly on a crucial area. So another little tip, if you place it on a little bit of an angle, if it was like an aligner model or a model for like a study model, for example, it will try to prevent placing any supports to the occlusal surfaces. That's a couple tips for models itself. Let's take a look at the next case. So the next case I have already set up. So I set this up prior to the call. And so this was automatic supports. This is using the key splint soft material. And you're probably looking at that wondering, why are there so many supports? Well, actually, there's quite a few supports, but they're actually quite small. They're only 350 microns at the contact point. And so these are very thin supports and will actually peel off like Velcro, like soft Velcro, which will leave a very clean surface behind. When you're printing a splint, it is extremely important, and I can't stress this enough, to always read the instructions for use for the splint material, because they may have angulation requirements that it needs to be printed on. And so you'll want to read the instructions for key splint soft, for key splint hard, for the Whitmix hard splint, or any other splint material that you plan on using. They may have certain restrictions for angulation that are found to be best for fitment and for clarity of the actual print that is splinting, or the splint that is printing. And so for that, let's say if you wanted to print on a 45, you can print it on a 45. If you want to print horizontally, we can print horizontally. And then if we want to print vertically, we can. I do want to show, if you are printing vertically, you may run into that same issue where you may have some support structures on the intaglio surface. That would not be ideal. So I'm going to remove the support file on this splint. I'm going to look at it from a side point of view. And I'm just going to angle that back a little bit. And let's go ahead and add some supports. We're going to go selected and then hit apply. Just to let you know, the build plate on the screen right now, this is actually the Asiga Max build plate. And so we can see what that looks like here. We can see the overall size of it. The build plate prior was the Asiga Pro 4K80, so we can see it is quite a bit larger. In fact, the build space on the Pro 4K80 is, 3 times the size of the Asiga Max, which is phenomenal. Let's talk about dentures. So if we want to nest a denture, this would be a no-no orientation. You could do this, however, what will end up happening is that you're going to have all your supports on this external surface of the denture. Now, you don't want to have a whole bunch of supports on that intaglio surface because that could affect the fitment. But I have found that with printing a digital denture, I found that the best orientation is actually vertically. And so I'll print it vertically or on a slight angulation with the intaglio surface facing the build envelope. Now, when I apply my supports, I'm going to turn off model inner support, and I'm just simply going to hit apply. And these contacts for the material that we're using, this is actually using the Dreve denture-based resin profile. And with that, it does provide quite a few actual support contact points. Now, if you didn't want so much, we can actually go ahead and undo it. We can maybe place it a little bit more vertical and then hit apply. Gotta plug in my laptop real quick. It's about to die. There we go. All right. So from here, we can see it is actually, it looks like that was a little bit of an increase in more supports. However, they're extremely small and they will peel away almost like Velcro. The most important aspect when looking at a denture is that we try to prevent the supports being on that mucolabial fold as much as we can, which that's going to create that true suction for the patient's oral cavity. A little feature when we are looking at the digital dentures and printing them, if we're printing a lower denture, for example, something that I would do is instead of putting the posterior region down on a lower denture, so imagine this was a lower denture and we didn't have the palate, I would actually want to rotate around and put the anterior facing down. And the reason why is because if we have two structures, for example, if it was like such, if we had two structures or two sides of the denture that were building together and then had to combine in the center, depending on the layering process or depending on the actual structure itself, you may see a little bit of a deviation line when they're combining to the center together in the middle. I would highly recommend actually printing with the anterior down on a lower denture. On an upper denture, because it doesn't have like a horseshoe style arch, you can actually print it just fine any orientation and be okay. What about the denture teeth? And so when we look at denture teeth, I see a lot of users, well, they'll actually go ahead and print the denture teeth with the occlusal surfaces facing the actual build plate. And I'm actually against that. And the reason why is because you spent all that time finessing the occlusal surface, and what will end up happening is you're going to have to remove those supports by hand, and you're going to ultimately change what that anatomy was that you're trying to create and trying to fabricate. And so instead of placing the occlusal surface down, I'm actually going to put the actual pocket side of the teeth facing the build plate. What that will do is it's going to apply the supports to the bottom side of the actual denture teeth. And that's not going to be the supports there. You can actually wisp those off with a fiber wheel, and you'll be able to maintain that dentition that you were trying to achieve with the design process. And so I'm going to go ahead and apply my supports. I'll hit apply. And just like that, we're ready to print the teeth for the denture. Now, I did show the denture on the Pro 4K build space. We can see that we can fit quite a few. You can actually fit about, I would say, 12 to 18 dentures, depending on size, on the Pro 4K. And then I was demonstrating the teeth being placed on the Asiga Max. All the materials are cross-compatible between the machinery, so any printer from Asiga can print any range of materials identical to another, just to let you know. When we look at bridges, so let's say this was a temporary bridge. The same protocol goes with this material here, or this type of indication. You do not want to print it with the prep side facing the actual build plate. You want to actually rotate around so that the occlusal surface is facing the build plate, and then you will apply your supports. So it's a little bit opposite from the digital dentures. because the denture, we're actually placing technically the interfacing side to the build plate. But for actual temporary teeth, you're going to actually rotate around and place the occlusal surface down, and this will prevent the actual prep surface from changing or altering. Last thing you want is any sort of open margin type structure. The next indication I have is the surgical guide. So let's say if I wanted to print a surgical guide, really orientation for the surgical guide does not matter. So you can print it in any orientation. I'm going to print this one horizontal to the build plate. If you print anything horizontal, or the shorter that the structure is, the faster it will be on the printer. Let me go ahead and run the supports for that. The crucial aspects of a surgical guide will be the interfacing aspect where the sleeve is. And so, for example, right here, let's say if there were support pins actually on the interfacing aspect where the sleeve was, I may want to remove some of those supports. And so I'm going to simply select on remove and then left click on the supports I want to remove. A little tip inside of Asiga Composer software. Let me go ahead. We have what is called a clip slider on the right hand side. And so you can actually view the slices. If you do remove any of the slices around the or on a structure itself, any supports on the structure itself, I always go through the clip slider to make sure that there's no crucial island points that need to be supported. A crucial island point, for example, would be like this little structure here. You can see that there's a support leading to it, but let's say on the interfacing aspect where the sleeve will be placed, if I had an island point starting out of thin air or thin resin, I would need a support there. And so I would want to go back to our support generation, go to add, and I could manually add in a support structure in those areas if necessary. This case where I removed them, it did not need those to be added back in. Surgical guides are quite simple to nest and support. The most challenging, I find, structure, which is the most unique structure, would be an RPD framework. And so RPD frames, because they are so, I want to call it such an organic design, and every case is so different, and you have stippling that you have to take into consideration, and clasps, and it's just such a unique structure, which is what makes 3D printing so perfect for it. However, you have to be careful when you're applying supports that you don't accidentally miss something. And so that's where I will go ahead and apply my supports. So I went up to support generation and hit apply. And then I will actually look at it from the underside. Little trick to get to the exact underside on Composer under the viewfinder bar. If you select it twice, it will automatically snap to the bottom. And I'm going to use that clipping plane, and I'm going to look for any unsupported overhangs. Now, the software algorithm that we use for finding the overhangs and unsupported islands is actually extremely powerful. So it's extremely rare that it would ever miss anything. However, let's say if I went and started to alter some of them. Let's say if I wanted to remove these support pins here, and I was like, you know what, I don't need these on these clasps. I'm going to go ahead and let's remove it here, for example, on that rest. Let's move it here, remove it here. Well, if I wasn't careful, I may have just accidentally removed a support pin, oops, from an island point. We can see that I did. So that unsupported island right there needs to have support on it. And so I would undo to that point. Awesome. Well, we just saw a lot of information, and I hope it was extremely useful. I apologize if it was all at once and maybe a little in your face, but we actually got to see a little bit of the technology about Asiga and what makes it special and unique. We're able to see the different materials that are available for the printer, plus so much more. There's over 500 validated materials available. And then beyond that, we discussed the different indications that can easily be 3D printed with an Asiga. There's actually no indication that cannot be. And beyond that, we're able to see a live demonstration of the different nesting properties and principles in the Asiga Composer software. I'm going to go ahead and conclude now. So if there's any questions, please feel free to ask. and we'll be able to go through and answer all the questions that you may have.
Thanks, Cory. I have a couple of questions here. And the first is, how easy is it to import a material file into an Asiga printer?
Absolutely, yeah. So that's a great question. And so let's say if I wanted to import in a profile, for example, let's go ahead and let's download one real quick. So remember, inside the presentation, I went to asiga.com and you'll log into your account. From there, when you're logged in, you're going to find a tab that says Material Library. And so let's say I wanted to use let's say Denture denture resin. So I'll find the denture resin I want to use, so Denture denture base. I would download it. And then from there, inside of the Composer software, I would act as if I was going to create a new build. So I'd open up the build properties window. And inside of here, there's a little gear. We'll go to import, choose Composer or the name of your computer, either way. And then it'll be in your downloads folder. So right there, we'll open it. And just like that, it's imported. That was a good question.
Excellent. The next is, does the Asiga require any CAD specific files for CAD software?
It's another good question. And so there are CAD specific settings. So for example, let's say if you're using 3Shape, ExoCAD, or Dental Wings, we actually do have pre-configured settings for our printer. And so it's actually found under the same user account. Underneath there, if we go to the, your account, we have a software library. And let's say if we're using 3Shape, I can go ahead and find the DME data that it corresponds to. That's a good question.
And the next is, will there be any special promotions between Zahn and Asiga for someone who's looking to purchase a new printer?
I would say absolutely, but you will have to contact your Zahn sales rep for that. And so if you contact your Zahn sales rep, they'll be able to let you know what the latest and greatest promotions are that are associated with the Asiga 3D printers and resins that they offer.
Awesome, and I can answer a little bit to that as well. There will be a special promotion for our live attendees. You're just gonna have to check your email in the next couple of days and you'll be able to see the promotion that's there. And again, contact your Zahn representative. Here is another one. When using different resins, how do you recommend long-term storage, specifically in the build tray?
Absolutely, so that's a great question. And so if you have for example, a resin tray that's already filled with model material and you want to use a different tray or a different resin, instead of emptying out that resin from that tray, it can be a bit of a sticky, gooey mess. We recommend actually either putting it back in the cardboard box, so put that tray back in the cardboard box that it came in, or we do offer resin safety trays, which are the little storage trays that you can place the resin bats inside of. That is only available on the Asiga Max. We do not have them on the Pro 4K at this time. If you are using the Pro 4K, use the cardboard box that it came with. Good question.